In today's video, we are going to talk about OctoMap. So in this video, we will start with introduction of OctoMap. Then we will talk about our project block diagram where we have implemented OctoMap in Webots. Then we will see a video of how the OctoMap is generated. Finally, we will save that OctoMap and we will open and use Octoviz to visualize the 3D point cloud. Let's start with introduction to OctoMaps. OctoMaps is a 3D mapping using octree as the data structure. So this technique is a mapping technique and not a SLAM technique. You will need to have some kind of localization technique in order to use this technique. For example, you can have a LiDAR localization technique or you can have a SLAM technique like visual SLAM. If you want to go in details and understand how the octree works, you should click here and it will open a paper where you can go through details of how this data structure is made. For now, we should talk about benefits of using OctoMap. First benefit is we can get a full 3D model where if we have any environment, we can get free spaces and occupied spaces in the environment for our robot to navigate. And also we can get unexplored areas for exploration robots to work. It is very easily updatable, so we can add or delete parts in the map probabilistically. Hence, this is a great map to use for multi-robots where your multiple robots can update the map and all the robots can have the updated map of the environment. Also, it is flexible because you do not need to know everything about the application when you map, because you can change the resolution of map and it can work in different applications. And finally, it is really compact. At the end of this video, we will see how small the .bt file of complete map will be. Because of this feature, we can save the map in very small size and it can be shared between robots easily, even if robots have bandwidth constraint. After looking at all these advantages of using OctoMap, let's get our hands dirty and let's start implementing and see the result of OctoMap. So the link of this project is given in the description where we have implemented this project in a repo named Robotics Picodegree in the OctoMap branch. So if you want to check out, you can clone this repo and check out to this branch and check the project. So now let's talk about blocks of this project. If you have been following Robotics Picodegree in this channel, the bring up package will be familiar to you. If you are new to this channel, you should have a look at Robotics Picodegree in our channel, where we stepwise implement the bring up package and the Webots world. So finally, we are using multi-layer laser scan, and in Webots you can enable the point cloud topic of that laser scan. What do I mean by that is from Webots we get a point cloud message of a multi-layer laser scan, but issue here is ROS package of OctoMap only accepts topic with type point cloud 2. So we use a package named point cloud converter to convert our point cloud to point cloud 2 type. And finally, when we give the point cloud 2 message to OctoMap, it also needs map to base link, which is provided by GPS from Webots. So when you have these two sources, OctoMap starts showing its magic. So finally, you will see in this video where slowly the map is built and OctoMap starts storing the map, and finally you have a complete 3D reconstructed map in OctoMap topic. So now let's see the implementation of the project. So I have Webots underscore workspace as my workspace setup, and in my source folder I have the Robotics Picodegree repo, which we just discussed in our block diagram. So I have Catkin made the repo and checked out to OctoMap branch. Now I just need to do, I will source it, ROS launch, bring up master.launch. So this launch file has an Arbiz environment and a Webots environment. So you see Arbiz here, you see a robot here. From the block diagram, we know that we have enabled all the sensors and now robot is ready to move. Sometimes this happens, so let's reset the world. So now we are able to see the world here, and let's make it small. So now what we will do is we will just move our robot in different rooms and it will capture the point cloud, and our OctoMap will save the point cloud into a single big point cloud. So for sake of time, I am increasing the speed of video by 2x. When we are ready with the map, let's save the map in .bt file. So we open a workspace, we source it, we do ROS run, OctoMap server, OctoMap saver. So this is the node name, and if we do -f, it will save the file name and we'll do house.bt. So it is listening to the topic and it is saving the map. So now if we see the size ls-la house, if we see the size -h, so it is 109 KB. So it is a very small file. All this point cloud is just saved in 0.1 MB file. So that's why we discussed that OctoMap is really compact in saving the data. So now we need to clone this GitHub repo, which is octomap/octomap, and they have a package named Octoviz, which we will be using for visualizing the data. So I am in Octoviz folder. If you go to bin, here this is the file which we made, which is house.bt. So I can do /octoviz and the file name house. So we can see our complete file in this format where this resembles like our house. As we mentioned in advantages of OctoMap, you can change the granularity of your map. So if you see, we can change how coarse or fine the map should be. You see, if you have an application where you don't want to have very dense map, you can have less granularity and reduce the size. Or if you want to have very fine map, you can have in this mode. We had kitchen, this is our bedroom, this is the other room, and this is the furniture. This can be shared between robots and can be updated. So this was all about today's video. Make sure you implement OctoMap and let us know if you have any issues. I would also like to know what applications do you implement with OctoMap. So if you like the video, do share and subscribe to Soft Illusion. We will be coming with many more such interesting concepts of robotics. Thank you.